everyone, and welcome back to another professional prep video. In this video, we are going to cover compound and equivalent Boolean expressions. So, as you know, in a previous video we covered truth tables, so this video will be a nice review and expansion of that video. So let's start by reviewing our or, and not operators in Java. So for our and, we have these two and signs. For our or operator, we have these two vertical lines. And for our not operator, we have an exclamation point. So these are our symbols that will tell Java what we're trying to do. So let's start with some examples here. So say that we want to print true and false. And we know that this should evaluate to false because the only time that an and expression evaluates to true is when all the operands are true. And in this case, we have a false, so this should print out false. And that is what we see in, down in the output window. Let's do the same thing for true. And we know that true or false should evaluate to true. It's the only time that a true an or expression evaluates to false is when all the operands are false. In this case, though, my bad, I'm using exclamation points. And sure enough, we see false and true done in the compiler. So now let's use the not. And so not only has two real possibilities. Not false is going to be true, and not true is going to be false. So let's use not false here, and we should see true. So the way we're going to do that is just like that. And sure enough, we're going to see false, true, true in the compiler, meaning that we have proven that Java recognizes these expressions. So let's get rid of that. Now let's do an example of using compound conditions. So say that we needed, in order to get into a certain university, say that we needed a 1300 SAT and a 4.5 GPA. I'm just making this all up as we go. So in order to use, and you need both of them to get in. You can't have one or the other. So obviously we know right from the bat, you might be thinking, use the and operator. And sure enough, we do use the and operator. So say that we have int SAT equals, let's make it 1290, and with double GPA actually, equals 4.6. So we know ultimately you should not be admitted with these credentials because you need at least a 1300 SAT. And while we do have at least a 4.5 GPA, we do not have the SAT. And both of the conditions need to be true for admission. So let's see how to use compound Boolean expressions here. This is going to be an example of a compound Boolean expression. If SAT is greater than or equal to 1300, and now you see that and operator from up here. And you can use parentheses, by the way, around the SAT greater than or equal to 1300. I'm just not going to for here. I just don't want to have an overflow of parentheses, but you can absolutely use it. And GPA greater than or equal to 4.5. Then system.out.print you are admitted. So you get in that case. And else. In this case, we don't need an else if, since there's only you get in or you don't get in. So we don't actually even want this curly brace here, since there's only one statement within the if statement, so you don't need curly braces. You only need the curly brace when it's two or more statements. Same thing goes for this else here. So else, if that's not true, you are not admitted. Harsh there. And I'm just going to close that. So now let's run this. And one thing that we should know, this is going to be our compound Boolean expression. Obviously, ifs and elses, they don't end with semicolons. These control structures here, even with loops, you'll see for and while loops, they don't end with parentheses, those with semicolons, these lines. So those are the exceptions I was referring to. Other than that, all these declarations and everything ends with our semicolon. So Here, the compound Boolean expression that I'm covering here is going to be right here. That's a compound Boolean expression. We run this and we're expecting you're not admitted, and that is what we get. And that's because we violate our SAT condition here. So say that we change our SAT to 1310, but our GPA goes down to 4.4. This should also say you are not admitted, and we see that down in the output box because the GPA is not high enough, and you need both standards. However, if we get our GPA up to a 4.5, now we do have the credentials to get in, and you see that you are admitted. So that's how that works. I just wanted to show you an example, and that's how you do compound Boolean expressions, just like that. Just combine the two with the and, or not, whatever you wanted to use. And I also wanted to cover the number of combinations for these truth tables. The formula is if you have n operands. So for example, when we were doing the true or false, true and false, those were two operands. We have one true and one false, so that's two operands. But we can also do true or false or true. That's three operands. And so the number of combinations to evaluate a certain truth table is going to be 2 to the n, where n is the number of combinations. N is the number of operands. So if we have 3 operands, then we have 2 to the 3, or 8. If we have 2 operands, then we have 2 squared, or 4 combinations. And you can see that the 4 combinations would be true if we wanted to use the OR operator, true or true, true or false, false or true, and false or false. So you can see that there, 2 to the n, where n is the number of operands. And also for an expression like not, we only have 2. Not true and not false, just the not alone. So now let's go into some short circuiting. So I just wanted to cover this topic just so that we understand it here. So here's the thing. Like I said, in order for a OR operator to evaluate to true, we only need one of the operands to evaluate to true. So say that we had true or true, or, and then we have this entire thing here, false and true, true or false and false. How about that? So, and we run this. Here, I'm going to print the results so that we can actually see this. Yeah. So let's print that. And we know that this comes out to true. But something that's interesting to note, if this first condition is true, then this entire expression is true no matter what, because this is an OR operator. So what Java does is it doesn't even evaluate this second condition. It's not necessary. The whole thing comes out to true. And likewise with the AND operator, if we have even one false operand, it doesn't matter how gigantic the second or third or fourth, however many you have operands are, this whole thing is going to come out to false no matter what, just because of that first operand alone. So Java will not even use this false and false here. It won't even look at that. It'll just print false because it knows that this whole thing is going to be false just from that first false and the AND operator. So that's called short circuiting. So now let's head more into the second part of this video, equivalent Boolean expressions. So just one fact you should know, truth tables of equivalent Boolean expressions are always the same. So let's use De Morgan's law as an example of this. So we might remember from our truth tables video, De Morgan's law, it's a very important law in programming. Not using it correctly can result in a lot of logic errors. So there's two sort of forms I'd like to say about De Morgan's law. Not A and B equals not A or not B. And you might remember this from our truth tables video. Not A or B is equals not A and not B. And what I'm going to do now is I'm going to show you some examples of this law using sort of like a proof using truth tables. Or we're not really going to make a full-on truth table. We're just going to print some examples to show everyone. So let's put in system.out.print not let's do not true, and let's do this first law here, not true and true. And yeah, not true and true equals, and what I'm going to do here is I'm just going to set these two equal, and so we will see whether or not they both evaluate to the same condition. If this whole statement will print true, it means they are equal, and false if they're not. So if that's equal to not true and or my bad, not true. So that's obviously a pretty large line of code there. Let me see if I made any compiling errors there. Yes, I did make a couple. So it appears that I have put in too many parentheses. Maybe I have one too many there. Maybe this is not a good idea, but let's try it anyway. Not true or not true. And okay, yeah, let's just put this into separate lines. We don't want to do that. Equals equals. So here we have our this, and then let's put in what Java calls to be the equivalent expression. So I think making mistakes in these videos is a good way for everyone here to learn and not make the same mistakes. I'm obviously typing here, so if I get errors, I'm trying to figure it out on the spot. So I think this is a good way for everyone else to learn as well. Hopefully you find that to be true. So let's just put it down here. Not true. My bad. Or, I always make that mistake. Or not false. So there we have our code segment for those two. And when we print it, oh my bad, this should be a true. Our operands need to be the same. And sure enough, we get false and false. And this proves one aspect of De Morgan's law, because think of these trues as A and B. This first true is A, the second true is B. So not A and B, and this is not A or not B. So this line right here says that they're equal because of De Morgan's law, and sure enough they are. We get the same value here. You can plug in anything. Say that we make A false. We run it, we'll get the same here. In this case, we get two trues. So this proves De Morgan's law, and there's also the other way to put it, the not A or B portion of it. And let me just run a couple examples there to prove that one as well. So we're going to change that up. Let's use false and true again. And sure enough, we get two falses this time, but once again, they're the same. And one more example, let's change the second one. Let's change B from true to false. And when we do that, we will also get the same. Yep, we get two trues in this case. So this proves partially. This doesn't prove all of it. There's still a couple conditions we could evaluate, but I'm not going to do that here. But that's our proof of De Morgan's law here using sort of truth tables. And it also shows us that equivalent Boolean expressions will always have the same truth table. That's something really important to keep in mind. That's all I have for you for this video. Please subscribe, check out our website, send us an email. We want to hear from you. Thank you very much, everyone. I'll see you next time to talk about comparing objects. Thank you, everyone.